Alright, hell yeah. So we got chapter 1 physics, you know what I mean? And here's the book that we're using. And we're doing this problem 55. So it's right here. It says, a sidewalk is to be constructed around a swimming pool. Alright, it measures 10 meters by 17 meters. Cool, plus or minus uncertainty. This is an uncertainty problem, so we'll get right to it. The sidewalks, though, has got to be 1 meter wide all around. So we got to do a little bit of visualization. And then it's like, I don't know, that thick. 9 centimeters thick. Let's say it was 10 centimeters thick. You should always know that 10 centimeters is about 4 inches. You know what I mean? Holy Toledo, you definitely have to come up with some ways to get from Canada to the United States without going through that border and spending 4 hours. Alright, so and it's what's the volume of the concrete? But basically, since this is a uncertainty problem, what we want to know is how uncertainties work. So we're going to say, hey, we got a bar, a steel bar, because we're in America, and it's going to be 10 inches long. Hell yeah, that's a long length. And anyway, this steel bar could be 11 inches and it could be 9. You know what I mean? Could be 9, but hell yeah, it might be 11. Just because we're just real crappy at measuring stuff. Nah, I don't know. But that's just how uncertainty works. You know what I mean? And then you would write it like this. 10 plus or minus 1, and then all in inches. Okay, cool. So now let's say we're going to make something. Let's say we add 2 of these 10s together. You know what I mean? And hell yeah, it should be 20. It should be 20. But hell, yeah, it might be only 9 plus 9. You know what I mean? Which would be 18. So right here, this would be 20 because you got 10 plus 10. But this would only be 9 plus 9. This would only be 18 inches. So I think we kind of get that. But, you know what I mean? This might be 11. You might be adding 2 11s together. You know what I mean? So you'd get 22 inches. There you go. There's your plus or minus. Oh, but you see what happened? If you just had 1 of them, it's going to be plus or minus. But if you got 2 of these, hell, if I want to multiply by 2, I have to, you can multiply the uncertainties, and I think we get that. So you could either just, if I'm going to multiply this length by 2, just go 10 times 2, plus or minus 1 times 2, you know what I mean? And then your uncertainty. So now you have 20 inches plus or minus 2 inches. And this is exactly what we get. Okay, so anytime you're going to be adding these lengths, you're going to add the uncertainty. Now, what's one way that we don't have to add the uncertainty? And I don't even know if this... So turn this into a proportion. And I think the easiest way to do a proportion is a percent. So we're going to go 10 plus or minus 1 divided by 10, because here's the uncertainty. 1 inch of uncertainty over a length of 10 inches times 100%. And then you don't write it like this in inches. You then write this like this. So 10 inches plus or minus 1 over 10, so 1 inch over 10 inches, you know what I mean, the uncertainty divided by the total length times 100%, and now we get 10 inches, and let me just do this in my calculator, just so, but no, this is 0.1, so you got 0.1 times 100, boop, boop, and then you got 10%. You know what I mean? So yeah, you got 10% uncertainty. So we're going to go, and then you write it like this, 10%. And this is just how you write it. You don't even have to put the brackets and then inches out here because this thing don't have units of inches. It's a percentage. And if you just do 10 inches plus or minus, and you go boop, boop, because the decimal place is 2, and you go 0.1, now this is fractional uncertainty. So now you have fractional uncertainty, and then this is percent uncertainty. And this is just actual uncertainty. So now, you know what I mean? Now I don't know what I mean. But you can do this. No, I gotta take a pause. Alright, hell yeah. So I caught myself for the first error. So if you do percent uncertainty, and then you're adding like 10 inches with plus or minus 10% uncertainty, plus another one of these 10 inches, plus or minus 10% uncertainty, you do not change this value. You just, now this is just 20 inches, because 10 plus 10, plus or minus 10% uncertainty. And you do not do anything to this. If you had absolute, because this is, absolute uncertainty is 10 inches plus or minus 1 inch, plus 10 inches plus or minus 1 inch. And then you would get 20 inches plus or minus. Then you add the absolute uncertainties. So now you got 2 inches. And even if you're multiplying by a factor, like let's say I want to add 4 of these together because I want to find the perimeter. I'm trying to make a, something that's 10 inches by 10 inches, welding all these steel things together. I know they're about 10, but they have an uncertainty of plus or minus 1. You know what I mean? So this thing could be either 44 inches in perimeter or 40 minus 4. It could be 36 inches. So how do we get both those answers? Well, we go 4 times 10 inches plus or minus the actual uncertainty, which is 1 inch, actual uncertainty, and then we go 4 times 10 plus or minus 4 times 1 because we're multiplying by the actual uncertainty. But if we had 4 times 10 inches plus or minus 10% uncertainty, this 10% does not change, or if it's fractional uncertainty, 0.1. If this is our fractional uncertainty, then you just do 4 times 10, plus or minus, and you keep the same fractional uncertainty. Because now we got 40 plus or minus 10%. What's 10% of 40? Well, that's 4. So we would have 44 or 36. And same thing here. 4 times 10 plus or minus 0.1 is a fractional uncertainty, 1/10. And this would be 40 plus... we just did it. Oh, no. 40 plus 0.1. 0.1 times 4 is 4, so you'd have 40 plus or minus the actual uncertainty is 4 inches. Okay, so now that's done, and now we're going to probably grab a new sheet of paper, and then we're going to try to find the area. We're going to say, hey, this is 10 plus or minus 1, and this is 10 plus or minus 1. Now what? So this was when you just add these. And anytime you add them, you can multiply by a constant out here, any constant you want, but still, you have to add up the absolute uncertainties, or, because here, before we flip to another page, let's say I know that this bar is 10 inches plus or minus 1 inch, you know what I mean? But this bar over here is 20 inches. But it's only plus or minus 1.5 inches. And I want to add them together. Well, just quickly in our head now, we're going to do 30, but now we're going to add the absolute uncertainty. So it's going to be 1 plus 1.5 is 2.5. So our answer is 30 plus or minus 2.5. Now, does this make sense? Because this bar could be 9 inches. Or it could be 11 inches. And this bar could be 21.5 inches, or it could be 18.5. So check it out. We're going to add these. 18.5 is kind of like 3 times 9 is 27. It is like 27.5. And then, so it could be that on the low end. On the high end, it could be it could be 31.5, add another, so 32.5. And does that make sense? We thought it was going to be 30, but it's going to be 32.5. You're adding 2.5, and that's what we get, or you're subtracting 2.5. Yes, so especially if you're measuring two things with two different absolute uncertainties, you have to do this. And if you were given this problem, you could be given this problem as a percentage. So 1.5 divided by 20 times 100. So this same problem, this bar is, you got one bar that's 20 plus or minus 7.5% uncertainty. You know what I mean? 7.5% error on that measurement. And this one is going to be 1 over 10 times 100. And this is a 10% error. So, or 10 plus or minus a 10% error. Now, if you get this as a math problem in a book, how do you add these together? Well, you're going to get something that's close to 30. You should always do that. First, just like, hey, screw these uncertainties and just get the answer close. Hey, about 30. Who cares? Let's move on with life. But how do you get this actual plus or minus? You can't, when you're just adding these things together, you can't do crap with the percent. You can't do crap with a proportion, a fractional uncertainty. You can't. That's when we multiply and divide, which we'll do on the next page. So the only way you can actually do anything is to convert them to absolute uncertainties. So you're going to take 10% times 10 plus, you know what I mean? And the uncertainty over here is 20 times 7.5%. So this is 0.1 times 10 plus 0.075 times 20. You know what I mean? Or it's a 1.5 times 10. There you go. See how I did that? I halved this and I doubled that. We're just doing mental math here. And now this is 1 plus, and hell yeah, now we just move the decimal place, 1.5. Booyah. Don't even need a calculator. Absolute uncertainty, 2.5. Okay, now if you just stayed for this video, that's how you, and we might just make this a video, and then we'll, but no, we do long format videos. But if we ended this video, what we learned is how to add and subtract. Oh, well, let's do a subtraction before we lose our friggin' minds. Yes, let's definitely subtract these because we want to know. Hey, I've got 20. I've got a 20 with the uncertainty of plus or minus 1.5, and then I have a 10 with an uncertainty of plus or minus 1, and I want to put the 10 right here. Whoa! Put the 10 right here, and then make a mark. Because now I'm going to I'm going to use this as my ruler, and then whatever this is what I want, and how accurate's this chunk going to be? Well, now this seems like a harder problem to do, but we can just do it. This one's either going to be 21.5, so it's going to be real long, or it's going to be 18.5. It's not going to be as long, and then. And we probably have to do this 4 times. No. We have to do the longest with the longest to get the max, and then the shortest with the shortest. You don't have to do the in-betweens. You know what I mean? You don't have to do the 21.5 minus, you know, this is the big one. You don't have to do this minus the 9. 21, you know, that makes no sense. But but this could be 11. So this is the big one. You might minus with 11. You know what I mean? And then what's this? This is going to be our max. Or you might minus with the 9. You know what I mean? And then what's this? Actually, no. This doesn't give us our minimum. I'm glad I caught that. Let's just do them all now. So this is 18.5, and yeah, we actually want to minus with the 11. That does give us the min. I'm glad I'm doing this. And then the 21.5. Oh, shoot. 21.5. My handwriting is just awful tonight. Okay, and now we're going to minus with the 9. Oh, booyah. So this gives us our max. You know, so we're going to go 21.5 minus 9, which is kind of like 21 minus 10, which is 11.5, but not quite. It's going to be 12.5. So there you go. So this distance is 12.5. And this is going to be 18 minus 10 is 8.5, minus one more, 7.5. Okay, so this measurement is either going to be 7.5 to 12.5. You know what I mean? Just by doing this. Now, since we know the properties that we just add, anytime that you add or subtract uncertainties, you add. So even though we're taking 20 plus or minus 1.5, and we're subtracting it from 10 plus or minus 1, we add the uncertainties. Got it. So now this is just going to be 20 minus 10 for our first value, plus or minus 1.5 plus 1. And now we're going to get 10 plus or minus 2.5. Now is that what we get? This would give us a value of 7.5 or 12.5. And hell yeah, booyah. But I'm glad I did this, because that was complicated and we ran into the hiccup. You don't just, if you're subtracting, you don't take big minus big. You take big minus little to get the max. Big minus little. And you take little minus big to get the min. You know what I mean? trying to use this as a ruler has uncertainty. And even a tape measure's got uncertainty. Nothing's Carl Sagan when it comes to splitting pies. Alright, so now I'm just making nonsense words. Okay, so let's move on. And so that covers it. If I wanted to end this video, this was a perfect video. This was add and subtract uncertainties. Maybe in my next video, we're going to multiply. Turn these into, we're going to make a, like a steel frame that's 20 by 10 with those uncertainties. And we want to know the area difference, you know what I mean? One's going to be small, one's going to be big, you know what I mean? So what's the percent area difference, plus or minus? And is it going to be exact? That's my question. Because we use this, when you multiply these things, I don't know. I don't think you get the exact amount, but we're going to find out. So thanks for joining me for this video, and hell yeah. Alright, hell yeah. Thanks for joining me. In my last video, we took like a 10-inch bar and two 10-inch bars, but they had uncertainty. 10 and 10, but they had plus or minus 1 uncertainty. You know what I mean? So one of these bars might be 11, and the other bar might only be 9. You know what I mean? And then so when we added them together, we'd either get a bar, we could either get 2 of the 9s at 18 or 2 of the 11s at 22. You know what I mean? So if you add 2 of these together, and then you just add the absolute uncertainties. But let's say I want to make a, let's say I want to find let's say I want to do, what do I want to do? I want to put 4 of them together, and I want to weld them, steel bars, and I want to find the area. You know what I mean? Area is like, you know what I mean? One of these is base times height or whatever. Find the area. We get it. So one of these might be at the smallest. You might have a small one and a big one. These might all be 9. So now the area of this is 9 times 9. That's 81. And the area of this is 11. These are all 11s. You know what I mean? Because they might be on the big side. And that's going to be area is equal to 11 times 11. And can I do this without a calculator? 11 times 10 is 110. Plus 11 plus 10 is 120. 121. Alright, hell yeah. Look at that. I was going to go right to the calculator for that. But 121. And then this is inches squared now. So now, if we now our percent uncertainty is going to be 100. Oh, and I think I get why they do this, because 100 minus 81 is kind of like 100 minus 8. That's 19. It's going to be 19. So you got 19 inches squared there. So you got plus. And how about this one? See, this is why they do it. I'm understanding this, because now your area is going to be the difference of 21 inches squared. So on the high side, and because if we just did this, we would have had 100 inches squared. So 100, and if we knew exactly this was down to the fraction of a fraction of inches and stuff, 10 inches, hell yeah. The area is going to be 100 square inches. But just because when you multiply and divide, it's not as nice and neat. So then you have to use kind of a fudge factor. You know what I mean? Just like hey, this is how we do it in the industry, and we're fine with it. Because you get 2 different values. This is not 100 plus or minus 19, and it's not 100 inches squared plus or minus 21. You know what I mean? Because one goes to 19, the other one goes to 21 inches squared. So how do they do it in the industry? Well, they say this. You have to, because you can't just do this. You can't say, hey, 10 inches plus or minus 1, and we're going to multiply these together. We can't just multiply the absolute uncertainties. That's for hella sure, because now we get 100 inches squared plus or minus 1 inch squared, and that's absurd. Okay, so I'm just going to show you why that's absurd right there. So what you do in the industry is you have to take these into into fractions of a whole, where the whole is the whole thing 10, and the fraction is the percent uncertainty, 1 over 10, and this is 1 over 10. Or you have to take them as percents, which is just multiplying by 100% on the fraction. Okay? And once you do that, if you multiply these two things together, then you add these up. You either add the fractional uncertainties, or you add the percent uncertainties. Alright, so let's draw this one more time. So you have 10. So this is how you typically see uncertainties. It'll be in parentheses if both these are inches. 10 inches plus or minus an inch. But if we do a fraction, let's do a percent uncertainty. You're going to go 10. And then you have to get rid of these parentheses. So you have to do 10 inches plus or minus, this is 1 inch, over 10 inches times 100%. You know what I mean? 1 divided by that times 100%. Hell yeah. Now you'll get 10 inches. Plus or minus, this is 0.1 times 100. So you go boop, boop, and you get 10%. As a fraction, you just don't do the over 100 part. So fractional uncertainty is just 0.1. And you don't need a parentheses because you're not putting any label. Because this is in inches and this is unitless. You know, it's a percent and this is definitely unitless. Okay. And now if we got to multiply two of these together, so that's the first thing to do. Anytime you're going to multiply. Oh, and how about this? Because some problems, you'd need to, you know, find the perimeter, you know what I mean, and then, you know, multiply by another, you know, something. Anyway, yeah, you do. Let's say this is just 1 inch and it's 100%. Anyway, sometimes you have to do two different things. You have to add two lengths together and then multiply. You know, in the same problem. So the first thing that you want to do is get all your lengths, you know, all your things, and I would write them like this. Write them like this and this. I would write them in all three forms. And then if you do that, then you can easily kind of pick and choose. Because now if we want to go 10 plus or minus 1 inches times 10 plus or minus 1 inches, this is going to be the area. Basically, hey, this length, your base times your height or whatever. And then how do we do that? Well, we're going to pick your poison. Let's just do this one because percents look nicer. But we're going to go 10 inches plus or minus 10% multiplied by 10 inches plus or minus 10%. And then it's just a rule because I showed you, hey, this is going to be a difference of 19 on the small side and 21 inches squared on the big side. It's not exact. So all right, so now we're going to have 10 inches times 10 inches. That's these two terms. And then plus or minus, and now you just add the percent uncertainties. So you're going to go 10% plus 10%. So now you're going to get 100 inches squared plus or minus 20%. And what's 20% of 100? Well, what's 10% of 100? 10% of 100 is 10, and then so 20%'s got to be 20. So right now your absolute uncertainty, a final answer, 100 inches squared plus or minus 20 inches squared. And like I said, hey, you're right in between. You're right in between 19 and 21, which is the actual. So I mean, this is a sweet spot. You know what I mean? Because I mean, if you use 9 times 9, if you use the smallest to get the perimeter, it's going to be 81. And this is telling you that your smallest could be 80. 100 minus 20. But then if you use the biggest, you're going to go 11 times 11. And we just said that was 121. Better do that just in case I got it wrong. Yeah, that's 121. And we said, hey, this is 100 plus 20, 120. So yeah, you're still off by 1 on the high side, and you're still off by 1 on the low side. But that's why it can't be exact. You know, that's why if you multiply and divide with uncertainties, you kind of just have to hit that middle ground. You know what I mean? It can't be 100% exact. Okay, so I think we can just kind of do our problem. And this is and this is also if you divide, you know what I mean? If you divided these, anytime you divide, you just have to add the percent uncertainties. So again, to recap, we got it in percent or fractional uncertainties, and then you would add the fractional uncertainties together or the percent uncertainties if you're multiplying or dividing. So you first do your multiplication or division on these two things, but then you have to add the percent uncertainties or the fractional uncertainties, and then once you do that, then you can convert 20% times 100, Well, that's 20 inches squared. So then you can get back to this, and then we can actually write it in that format of 100 plus or minus 20, parentheses, inches squared. And that's kind of how they like it. Alright, so that's plus or minus. I got a physics problem I want to do in this book, so maybe we'll do that in a separate video, but that'll be the next video we do. Alright, thanks for joining me, and that's a video.